Students, welcome once again to the Oval Academy of Education. In today's video, we are going to discuss here with ICSE Class 8 Maths. Book is Foundation Mathematics by Professor R.S. Agarwal. Right? Chapter today we are going to discuss is rational chapter first, that is rational numbers. So before proceeding into the chapter, let us do our basics right in respect of this chapter. So first thing I am going to explain you here is natural numbers. So what are natural numbers, children? So all counting numbers from 1 to infinity are known as natural numbers. You already know. Second is whole numbers. Whole numbers. When we include 0 in these natural numbers, they become whole numbers from 0 to infinity. Right? Next is integers. So every whole number and every natural number along with its negative form is known as integers. Right? If I write like this, -5, -3, -4, -2, -1, 0, 1, 2, 3, 4, 5 up to infinity, these positive and negative numbers are known as integers. Right? So we can call these as positive integers from 1, positive integers, or we may also call them non-negative integers because they are positives. In the similar way, these may also called negative integers, or we may also call them as non-positive integers. Right, students? So next thing we are going to discuss here is fractions. So when we write the numbers in this form, they are called fractions. These are P and Q are here natural numbers. Right? Example we can take here 33 upon 67, 5 upon 7, 9 upon 11. These are all fractions. Right? So now we will move on to the rational numbers. Rational numbers, they can also be expressed in the form P upon Q, where here P and Q are integers, right? And second condition is what? Q is never equal to 0, right? So denominator of the rational number would never be 0. So for example, we can take them as 13 upon 37, 103 upon 219, etc., etc., right? These are rational numbers. So if I write minus 3 upon 8, is it a rational number? Yes, definitely it is a rational number. Minus does not divide the numbers to be rational. Only condition is this denominator should never be 0, right? If I write this 102 upon 5 upon minus 2147, it is also a rational number, right? So next thing we are going to discuss here is, can I write 0 in the form of rational number? Yes, 0 upon 1. 0 can be written as this. So this is a rational number. Numerator can be 0, but denominator cannot be 0, right? So we cannot write this is a rational number. We cannot write like this. This is not a rational number, right? Keep in mind, every integer is a rational number. Every terminating that is not repeating number like this is also a rational number. If I write 2617 upon 1000, so it would become 2.617. So these every terminating number is a rational number, right? Every non-terminating number is also a rational number, right? Non-terminating number is also a rational number. So next thing we are going to discuss here is positive rationals. What are positive rationals? Students, if I write fraction like this, where numerator is positive, denominator is positive, so it is a positive rational, right? If both are negative, so this is also a positive rational, right? Minus minus plus, right? Is there negative rational? Yes, definitely. So negative rationals are also there. Numerator and denominator with opposite signs, like this. It is positive, negative. I write this is positive. So this is negative rational, right? In the same way, if I write 61 upon minus 14, this is positive, this is negative, so this is also negative rational. Keep it in mind, right? So now let us move on to our exercise exercise is exercise 1a. So question number first is express minus 64 upon 112 as rational number with denominator 7. Right, students? So here is solution of question first. So students, to express this minus 64 upon 1112 as rational number with denominator 7, so we will take this in the simplest form, right? So simplest form, we will divide this with the common table. The common table here is 16 4 ja 64, 16 7 ja. So by taking it in the simple form, we have got the fraction with denominator 7. So this is the fraction, this is the rational number with denominator 7, right? We have expressed this in the rational number with denominator 7. Now solution to question second is minus 48 upon 60. We have to express this as rational number with the denominator 25. Before expressing that, we will take it in the simplest form. The common table here is 12. 12 4s are 48, 12 5s are 60. So this would become minus 4 upon 5. Now we have to take this with the rational number with denominator 25. We will write this here. Denominator, we require denominator 25. We will write it here. So how 5 can be converted into 25, or we have to simply divide 25 with 5. Right, students? So 5 5s are 25, right? So we have got 5, so we will divide this by 5 and numerator with 5 and denominator with 5. 4 5s are minus 20, 5 5s are 25. So we have expressed minus 48 upon 60 with the denominator, rational number with denominator 25, right? So this is our required answer. So let us move on to the next question. Express each of the following rational numbers in the standard form. So students, what is standard form? So standard form of the rational numbers. A rational number like P upon Q is said to be in standard form if P and Q are integers. These are integers having no common divisor. No common divisor other than 1. If these are having no common divisor other than 1, then they are in standard form. And the second condition is Q is positive, is always positive, not negative, right? So we have to express this in the standard form. For that we will do what? Write it minus 12 upon 30. So Q first Q is positive, right? So here Q is positive, and the second condition is no common divisor other than 1. No common divisor other than 1. So if we see there is any common divisor, yes. So common divisor would be 6 2 ja 12, 6 5 ja 30. So now after this, the numerator and denominator would not have common divisor other than 1. So this is the standard form of minus 12 upon 30. Right, students? So this is the standard form. Simplest form is the standard form. Right? Now we will go to the minus 14 upon 49. Q is positive, denominator is positive. So first condition is okay. Now common divisor, common table, 7 2 ja 7 7 ja. So this is the simplest form. We can find no other divisor other than 1. So third, 24 upon minus 64, 4 4, they would go on the table of 4. 4 6 ja 4 6. Oh, sorry. So here Q is negative. So what we will do now? We will make this denominator positive by doing what? Multiplying both with minus 1. Both with minus 1. So if the numerator becomes negative, there would be no effect, but we have to make this denominator positive. Minus minus plus 64. Now we will find the common table. Common table would be 8. 8 3 ja 24, 8 8 ja 64. Our answer would be minus 3 upon 8. So we will move on to the question 4th. Minus 36 upon minus 63. So for both are negative, we will make them positive by multiplying with minus 1. Minus minus plus, minus minus plus. So 9 4 ja 36, 9 7 ja 63. So this will be right, students. So this was question number first. We have solved it here. Now we will move on to the question number second. Question number third. We have solved it here. Now we will move on to the next question. Now question number 4 is compare the following pairs of rational numbers. We have to compare these pairs of rational numbers. So solution is here. First is 15 upon 32 and 17 upon 24. So students, for comparison, first we will take LCM of the denominators, right? So LCM of 32 and 24 is 8 4 ja 8 3 ja 4 3 ja 12, 8 ja 96. So LCM is 96, right? So 96 when divided by 32 will give 3 into 15 45, and here 24 4 ja 96, 17 4 ja 68. So which one is greater? So this one is greater. Therefore 15 upon 32 is smaller than 17 upon 24. right? So now we will move on to the second. Second is 10 upon 11 and 17 upon 18. So again these are prime numbers, we will multiply them, their LCM will be obtained after multiplying them. 11 8 ja 88, 11 1 ja 11 plus 8 19. 198 when divided by 11 will give us 18. 18 into 10 180, and 18 11 11 into 17, 11 7 ja 77, 11 1 ja 11 plus 7 18. So which one is greater? This one. So therefore fraction of this is 17 upon 18. So 17 upon 18 is greater than 10 upon 11, right? Now we will move on to the third. Minus 5 upon 12 and minus 3 upon 4. So they are divisible on common table, and bigger one is 12. So 12 would be the LCM. So 12 1 ja 12 into 5 minus 5, and 4 3 ja 12, 3 3 ja 9. So this is minus 9. So which one is greater? In minus, the smaller one is the greater, so this is greater. So fraction of this is this. So therefore minus 5 upon 12 is greater than minus 3 upon 4. Right, students? So next we are going to take part 4th here. Part 4th is minus 7 upon 24 and 9 upon minus 20. So LCM of 24 and 20 would be 4 6 ja 24, 4 5 ja 20, 5 6 ja 30, 4 ja 122. Sorry, 120. So one of them is carrying negative minus sign with it, so LCM would also be in minus, right? Now 24 5 ja, this is minus 5 into 7 35, minus minus plus, this minus becomes plus, right? And here this is 26 ja 120, 9 6 ja 54, this would carry minus. This would carry minus. So this would minus, it would also become plus. So minus minus plus, right? When I am going to divide this by this minus 9 6 ja 54. So this one is greater. So therefore minus 7 upon 24 is less than 9 upon minus 20. So this was your question number 4th. Now we will move on to the next. Question number 5th. So question number 5 is arrange in ascending order. Ascending order means low to high, right? So for that we have to make again comparison. So 5 upon 6, 7 upon 9, 11 upon 12, and 13 upon 18. We will take LCM of the denominators, right? 6, 9, 12, and 18. So 3 3 ja 9, 3 2 ja 6, 3 3 ja 9, 3 4 ja 3 6 ja. Again 2 1 ja 3. So from here 3 2 ja 6, 2 ja 12, 3 ja 36. So 36 would be the LCM. Now 6 6 ja 36, 6 5 ja 30, 9 4 ja 36, 7 4 ja 28, 12 3 ja 36, 11 3 ja 33, 18 2 ja 36, 13 2 ja 26. Now we will arrange these from low to high in this order. So this is the lowest, and its fraction is this 7 upon 9. So sorry, this is the lowest, 26 is the lowest, and its fraction is this. So we will write 13 upon 18. Second one is this, its fraction is this. So order would be like this, right? So next one is 30, its fraction is this, and this is the highest, so its fraction is here. We will take the fraction from here. So this is the ascending order from lowest to the highest, right? Now we will move on to the question number 2. Let me change the color. Question number 2 is 5 upon minus 7, 9 upon 14, minus 5 upon 6, and 7 upon minus 12. Question is just like this, but we have to keep in mind the minus sign and its rule. So again, LCM of the denominators. So 2 7 7 3 6. Again 3 7 7 2. Now 7 1 1 1 2. 7 2 ja 14, 3 ja 42, 2 ja 84 is the LCM. Now we will see this one is in minus, this one is in minus, so minus minus has become plus, so our LCM would be plus 84, right? Now we will divide 84 by 7, so this is of minus, this is of plus, so 12 7 ja, so answer would be minus 12 into 5, minus 60, right? 14 6 ja, here it is minus, 9 6 ja 54, it would also carry minus. Here 6 14, 14 6 ja 84 into 5, 14 into 5 70, this is also carrying minus, so it would also become minus. So 12 7 ja 84, 7 7 ja 49, this is also carrying minus, so this would also become minus. So now all are in minus. In minus, lowest is the highest, highest is the lowest, so we have to find out lowest. So this is 70 is here highest in this, so its fraction is what? Fraction of 70 is this one, so minus 5 upon 6. Second highest is 60. This one, its fraction is this. So our answer would be minus 5 upon 7. Third highest is this. So its fraction is minus 9 upon 14. And last highest is 7 upon 12. Sorry, 7 upon minus 12. So this is our ascending order. Right, students? It is easy. You can do the remaining two parts, that is this one and this one yourself. This is your homework. If you face any problem, then please write us in our comment section. Now we will move on to the next question, that is question number 6. Right, students? Represent each of the following numbers on the number line. So first one is 5 upon 6. First one is 5 upon 6. So students, we will draw the line here, number line here. Right, so this is the number line, and on this number line we will take the middle point O. So on this side is minus, on this side is plus. Right, so here you have to keep in one thing in mind: each point of division represents an integer. Right, this represents an integer. Each length between two successive integers is called a unit length. So this length would be called as unit length. Keep it in mind. Right, so now our question is 5 upon 6. Right, we have to divide the length between 0 and 1. 0 and 1, keep it in mind, into 6 equal parts. Right, so how we will do that? 1, this is 1, this is 2, this is 1, 2, 3, 4, 5 and 6. Right, so 1, 2, 3, 4, 5, 6. Right, and now for showing this 5 on the line, number line, I have to take 5 parts out of that 6. So 1, 2, 3, 4, 5. This is the 5 part out of that 6. So what would this represent? 5 upon 6. So here this is 1 is written here. So to represent 5 upon 6, I will write here 5 upon 6. right students? So this is the, let me say this point P is the point which is representing 5 upon 6 on the number line, right? So let us do second now. 14 upon 3, we will write it in a mixed fraction. So 3 4 ja 12, 2. We will represent this on the number line. Here 4 are the equal parts, or 3 the 4 full unit lengths, and 2 upon 3 are the divisions on the number line, right? So first we will take uh, 4 equal lengths, that is unit lengths on the number line, right? This is 0. So 1, we will 1 2 3 4, 1 2 3 4, right? Let me say, let's take it 5 also. So we have taken 4 full lengths here. Now we have to show this 2 upon 3 on the number line. So we will divide, take 1 2, and by counting this has become 3. So we have to take 2 out of these 3, right? So these 2 out of these 3, 1 1 and 2. So this point P is representing our 14 upon 3, right? 4 and next two divisions out of the next 3. So this is 14 upon 3, right? So now we will move on to the third. Third is minus 3 upon 7, right? So no need to panic, this is only in the minus, sign has changed. So we have to deal with minus, so we will take -1 -2, right? So we will divide this into 7 divisions. So 1 2 3 4 5 6 and 7 here, right? So out of these 7 we have to take 3, right? 1 2 and 3, this is the third one. So we will mark it as point P and show it as minus 3 upon 7, right? So now we will move on to the question, part fourth. Part fourth is minus 17 upon 5. It is a bigger, so we will make its mixed fraction. Minus 5 3 are 15, 2 remaining, 5 3 are 15 plus 2, minus 17 upon 5. Now we will represent it on the number line. So students, I am going to draw this here. So we have to deal with only minus, so I can start it from here. This is plus 1. So 3 complete parts in the minus portion are needed. Sorry, so I will write minus 1, minus 2, minus 3 and minus 4 here, right? So now I will make divisions. 3 are complete, 2 minus 2 upon 5 are the further points, right? So 2 upon 5, so I will make 5 equal divisions beyond 3. So 1, 2, 3, 4 and 5, right? So now I have to take 2 out of these 5. So 1 and 2, I will mark it as here. This is my point P, and this is minus 17 upon 5. This is representing my minus 17 upon 5, right? So now this is, we are going to do the last part here, that is part 5th. So part 5th, I will take this color. Part 5th is minus 2 upon 7. So again I will draw the number line. As I have to deal with minus, so I can start from here. This is 1, 2 complete divisions, minus 1, minus 2, minus 3, right? Now I will make 7 divisions after 2. So 1, 2, 3, 4, 5, 6 and this one 7. So 7 out of 2 I will take, 2 out of 7 I will take. 1, 2, this is 2. So this is my required point P, and this is my representation of minus 2 upon 7, right? Or I can write like this way, minus 2 upon 7, right? So this is the representation on the number line. So now we will move on to the next question. So next question is, state whether each of the following statements is true or false. Is true or false, right? Let me expand it. So every whole number is a rational number. Every whole number is a rational number. I have told you earlier, this is true, right? Every integer is a rational number. Yes, every integer is also a rational number. True. So now is this equal to this? So if I solved this side, 2 plus 4 has become 6 and 4 plus 3 7. This is not equal, so this is false. Minus 5 upon 6 equal to minus is greater than is less than minus 6 upon 5. So this is also false, right? Minus 3 upon minus 4 is a negative rational number. No, this is minus has become plus, so this has become false. 0 is a whole number, but it is not a rational number. 0 is a whole number, but it is not a rational number. This is not good, because we can write 0.1, 0.7 or 0.8, anything. So this has made this statement false. So students, this was your exercise first A, and so this question number 8, it will done by you. This is your homework. If you face any problem in this question, you can write us on the comment sections, right? So now it is time to go. If you have thanks for watching the video. If you have understood it well, then please make more and more likes, subscriptions of our channel. We will meet with next exercise in the next video. Till then, it's goodbye. Thanks for watching the video.